Hi, I'm Nigel Griffiths. I work in the Advanced Technology Centre in the UK, part of IBM Europe. In this active memory sharing movie, we're going to look at some simple monitoring of just a few logical partitions using the shared memory. This is the configuration that we set up in the AMS setup movie. We've got 3 logical partitions that are going to be using the shared memory pool and 1 using dedicated memory. So here's my HMC. I'm going to use this machine called Silver. It's a 520. It's got 4 CPUs and 16 gigabytes of memory. In that I have a virtual I/O server that will of course be using dedicated memory. Then I've got a logical partition up here, number 2, and that's going to be using dedicated memory as well. It's got an ID, a logical partition ID of 1. These 3 here, 3, 4 and 5, are going to be using the shared memory pool, and they also just happen to have logical partition ID of 3, 4 and 5. That makes things easier. And let's have a look at what the pool is currently set to. It is a property of the entire machine, so we have to select the machine here. We go to configurations, virtual resources here. There's the shared processor pool, and here's the shared memory pool. So the pool size is 4 gigabytes. I can extend that up to 12. Can't actually do that on this machine at the moment because other dedicated memory partitions are taking up the memory, but we could grow that up by 2.2 gigabytes. If we select here the paging spaces, so here are the devices that I've named on my VIO server so that they are going to be used for AMS paging. Now I just happen to call the logical volumes that I'm using in this case AMS 1, 2, 3, 4, or 5, that's my naming convention. Of course, it's recommended that we use LUNs on a fiber channel disk subsystem for extra performance, but I've kept it simple here. They're actually connected, the 3 here are connected to my 3 logical partitions, 3, 4 and 5. You can't dictate which logical partitions gets connected to which device. Now that I've logged on to the VIO server, I could have logged on to one of the other partitions, and I'm running Topaz minus capital C. And we can see here's the VIO server and LPAR2. These guys have 2 gigabytes of memory each, but we can see they're at the top now. There has no physical memory in here. These are dedicated. When we say they've got 2 gigabytes of memory, they really do have 2 gigabytes of memory. 3 and 4 here both have 2 gigabytes of memory, but in this case it's logical memory. Now remember, the pool size was 4 gigabytes, and the 2 plus 2 will fit in the pool, so we have no pressure on AMS to do any paging at all. Yeah, it can just give the full 2 gigabytes to those 2 logical partitions. And now start up the 5th LPAR 5 partition, and of course then we'll have 6 gigabytes of logical memory that will not fit in the 4 gigabytes in the shared memory pool. So give me a second, I'll come back. I'll just activate that. We can see here now that 3 and 4, using the shared pool, have been asked to give up some memory to let the new logical partition have some. This is AMS asking for loaned memory from the logical partitions, in this case AIX. Once the logical partition has started, we can then use the Topaz -C to actually see how much memory it's got. Now I'll restart the Topaz -C here. In 10 minutes or so it'll actually find that new logical partition, but I can force that by actually restarting it now. Okay, we can see the new partition here, and the memory has been split between these logical partitions. If we let them run for another 10 minutes or so, you'll find they'll actually get to fairly close having the same amount of memory each. Now in this case, my logical partitions here are not doing much at all, so there's no high demand on memory, and AMS will just move the memory between the logical partitions and even them out. In the next phase, I'm going to start running some workload on one of the logical partitions, and it start demanding memory, and we should be able to see it stealing that or getting that loaned from its peer logical partitions. Okay, in LPAR4, which is sitting at the bottom at the moment, I'm going to run an application that's going to grab nearly 2 GB of memory. So let me just start that off now. We can see it continue to go up, and the other 2 logical partitions slowly loaning more memory to help out their peer logical partition. So we're in cooperation mode here. Now in a more realistic example, when we have a lot more logical partitions and they're all running workloads rather than my idle ones here with one busy, we'll see that each of the logical partitions will be competing for memory when it touches pages, demanding more memory in, and having to loan out memory if some other logical partition has more pressure on memory and needs it. We also note that the memory moves over a period of time. We don't want the AMS to kick in and suddenly panic and start flushing gigabytes of memory out into its paging spaces, only to find that 1 second later, oh, we didn't actually need it, and then have to page out a whole lot of other things to bring them back in. So we want it to flow the memory between the logical partitions. I've just noticed here that we now got up to the 2 GB that we're entitled to, so AMS will now back off. This logical partition has all the memory it actually can demand. Any more paging that's required will actually be done at the AIX level if it's got to maintain more virtual memory than physical memory as it has its maximum. I can of course go into the HMC and increase the size of the pool if we were doing too much paging in our VIO server, and we should monitor our VIO server to see what's going on. Or I could actually increase the logical memory given to this logical partition. I could change that up to perhaps 3 GB, and it would in this case loan more memory as it's the only one under high pressure of memory from its other logical partitions. Now I've stopped the workload on this LPAR4, and you can see at the top here I had 2 GB of memory, and I'm starting to run workloads on other logical partitions, and we can see this logical partition giving up memory in here, slowly increasing the amount of loaning that it's doing, and it's actually using less memory. I've stopped the workload on this particular machine to free up some memory. And I've cut out a couple of minutes there of monitoring this. We can see now it's gone down to about 1.5 GB of memory here, and it's loaned nearly half a gigabyte. If we look at the global view here now, we can see LPAR3 is busy running a workload, again demanding memory, and we've split out the memory that we have in our pool across our logical partitions based on demand. In a much larger machine with more logical partitions, we'd be looking down here to see where our memory currently is. We'd have to be looking at the VIO server to see how much paging it's doing to the paging devices, the AMS paging devices, and we'd also have to have a look at the AIX on each of our logical partitions to see how much paging they're actually doing as well. Well, that is simple monitoring. In the next movie, we'll look at a more complicated example when we have all three logical partitions using memory quite a lot, and we'll look at who's paging and try and explain why they're paging.